Good day, everyone. Welcome to today's SecurityBoulevard.com webinar. We're excited that you've joined us. We've got a very topical subject today, lessons from the FinTech trenches, securing APIs. Today's webinar is sponsored by Salt Security. My name is Mitch Ashley. I'll serve as your host and moderator. A few housekeeping items we want to cover. We are recording the webinar, so sit back, relax, just take in the information that we're going to be sharing with you, things that you'll pick up during the conversation today. You'll also get a recording of the webinar and the slides, so you don't have to worry about those details. You can write something down if you want, but we will hope that you're engaged with us and we enjoy the conversation with you. Speaking of that, we love questions. I know that our speakers today are very much enjoy the engagement with our participants. So please enter your questions into the GoToWebinar questions tab anytime during the hour, and we will get to those as soon as possible. So please do that. So let's move on to our topic today, lessons from the FinTech trenches, securing APIs. My distinct pleasure to introduce two people to you, Nir Valtman, who is head of product and data security with Finastra, and Michelle McLean, who is with Salt. And Michelle is a strategic thought leader in security for a long time. I've known Michelle for a few years now, and she's one of the experts I rely on to go to for information about security. Welcome to you both.
Thank you so much, Mitch. Glad to
Great.
be here.
Good. Why don't we just do a brief introduction? Nir, if you want to tell us a little bit about what you do at Finastra and what the company is.
Yeah, definitely. So thanks, Mitch. I think I'll start with who Finastra is and what we're doing in terms of the ecosystem, and we'll get to the security topics later. So I'll start with what Finastra does. I actually have a slide for that. All right, can you see that slide? Mm-hmm. Awesome. So so Finastra is one of the top 3 largest fintechs in the world, and we provide a variety of solutions. It can be payment solutions and treasury capital markets, corporate banking, retail banking, risk systems, and such. And most of those systems traditionally were core banking systems, meaning those systems that usually sit between the employees in the bank and a bunch of other firewalls that touch, legacy systems. But the reality today is that many banks want to innovate, and they want to be more open in terms of APIs. There's additional aspect of that we actually support fintechs, and I'll talk about that in a moment. So one of the strategic initiatives that is driven by our CEO is actually having a platform called FusionFabric.cloud. It's also the website that makes that connection between makes that connection between the banks and the fintechs. And as I said, everything is exposed through APIs, meaning if something goes wrong, it actually hits the core banking system in the bank. So if I'll maybe double click for a moment about FusionFabric.cloud and the story that we're trying to solve, I'll talk a bit about the entire ecosystem that we're building. So as I mentioned, these are the lines of businesses that we have in the company. Each line of business has multiple solutions that our customers use. It can be, of course, big banks, small banks, credit unions, and such. And on the other side of the platform, we have the producers. Every platform has producers and consumers. So on that side, we do have the producers. The major attraction that we have is fintechs that develop applications to support specific financial processes. I'll give you a few examples to kind of emphasize how that works, because that will give context to the rest of the conversation. In some cases, it can be very simple functionality that part of the banks don't have. Part of the banks don't have, let's say, bill pay functionality. Well, it took us a couple of weeks to actually work with one of those credit unions to develop a bill pay functionality through the platform with one of the apps that actually does it. So this is more of like a B2C or B2B2C type of an application. Another type of application is something that looks at your transactions and every couple of days, based on machine learning, which is a thing now, right? It actually does micro savings on your account. And this is something that is more of a B2B because there's no interaction between the user and the system. And the last one is actually something that that supports the employees in the bank, which is, we call it a B2E. Similarly, if you need to do some, trading acts or provide any recommendations, or another example of an app that we have is an app that helps us to predict a consumer churn from a bank. So that all of that is something that that is part of the same ecosystem, and obviously we support additional developers on the system. But the entire idea of the platform is that this is how platforms work. More consumers. Because you have more consumers, you have more interest from the producers. That of course gets to a situation where we have more apps. When we have more apps, we have more data, and then it brings more consumers and such. So this is how it works today. This is the ecosystem. It's in production. We have already quite good traction into the platform. So that's what we are trying to solve. We also have additional applications beyond that obviously are SaaS and can be accessed directly. But this is where we actually started with API security. Now we're obviously much beyond that, but that just sets the context.
I'm excited. We'll get into sort of the evolution of your API security. I think you've done a really good job, Nir, of setting the table for us. And I started my career in finance. It didn't look like anything like this, so it's much more complex than when I began my career. Michelle, I know that you work with a lot of organizations. We've always had APIs for a long time, but API security is a hot topic. Why is this elevated to the level that it is today, that organizations like that Nir is with, that they're really making a concerted effort to work on this?
Yeah, I think we're seeing a few dynamics at play, and you could kind of hear it in how Nir was describing some of the interaction amongst the producers and the consumers and all of this. There's kind of a blurring line, if you will, almost between APIs and apps. And APIs, if you think about it in days of yore, you're absolutely right, Mitch, they've been around forever, but they used to be fairly limited in their functionality, fairly small in scope, not super pervasive. You did all your internal stuff and then you had a little bit of glue to something else outside. But now, APIs underlie all modern apps really, and particularly revenue generating apps like Nir's describing. And we've seen this evolution. And if you think about somebody in Nir's position, we have a lot of empathy for the people sitting on the security side because they're in a really tough spot. If you think about how app dev has changed, we've been living in this world for a while where things just sort of get released, right? Developers are just pushing stuff out all the time, and security's got to go catch up. And there may or may not be a lot of collaboration about sort of what's coming down the pike. And I think, the real struggle can be that security may not have been told a whole lot about what's going on, and yet they're still on the hook if there's a breach. And I think APIs are just making this worse, right? The rate of pace of change, the importance of the APIs now, they're far more functional, they're far more diverse, they're internal, they're external, there's just a lot going on. And I think, one element that's interesting is because APIs have been around for a long time, there's kind of a little bit of complacency about it. Well, we must have figured out security for APIs because we've had APIs for 15 years. But we kind of haven't, because they are so different. They're playing a different role. They're sitting in different places in our infrastructure. Coincident with everything moving to the cloud, there's a lot that has changed, and people are a lot more exposed than sometimes they realize. And the existing tools just really don't cut it. We just yesterday, in fact, released the industry's first State of API Security report. There's a whole bunch of really interesting findings in there. One of them is that 91% of the people surveyed have experienced a security incident in the last 12 months. And the rate of API traffic growth. It's sitting at around 50% amongst the customers of Salt itself. We extracted some data from the SaaS platform. So API call volume was kind of increasing at this fairly steady rate of about 51%. But the percent of traffic that's malicious traffic in that API call traffic is growing at 211%. So, you know, businesses like Nir's describing, they're very reliant on APIs to deliver functionality internally, externally, connecting partners, connecting customers, but the attackers have figured that out too. And it makes APIs a super attractive target. So we're just seeing a lot more interest in trying to get on top of this and get beyond the first generation tools that we've lived with for 10 or 20 years to get more sophisticated about what's happening at the API level.
Yeah, I think that your point about first generation tools is spot on, because APIs aren't just an external thing to get outside or to get inside. Applications are built on themselves, APIs across the entire, all levels of the app, right?
Exactly.
It's the boundary condition.
Right, and that old notion of, you know, this was just to go from inside to outside and it's kind of limited in the scope. Yeah, I can drop a little box there. It doesn't have to be super smart, doesn't have to be super sophisticated. I'm covered. But that's not how APIs are today. And when you think about the advent, I'm sure, you know, along with all of you're seeing from Nir's description here, I'm sure Nir, your team is using, you know, microservices and next gen app dev stack and all that to build this stuff. And you can't drop a box in the middle of all your microservices and think that that's going to work. So it's a very changed landscape.
It has. Speaking of landscape, if you don't mind, we've got a poll here. Would love to get some feedback from participants. I'll go ahead and launch that poll. We're asking sort of what approach, what API gateway do you use? There's no wrong answers here. We're just trying to, right answers. We're trying to get a feel from folks. Sort of what are you doing? Using products, using options from the cloud providers or hosted managed service gateways, things like that. Or maybe you're, you know, relatively new to this conversation and maybe you don't know if you're using something to do this. So we've got, we're getting questions rolling in. I feel like I should be playing the Jeopardy music in tribute to Alex Trebek, who we lost, of course. But if we'll just a few more seconds here, we'll give it maybe 5 or 6 more seconds. Keep those votes rolling in. You know, there's kids somewhere that we're going to be supporting. No, I'm sorry, we're not collecting money. So that's a different telethon than our event today. So great. Looks like I'm sorry. Go ahead, Nir.
There's no option for we developed it by ourselves.
No, there isn't. Well, you can always put that
would
in.
be the other gateway. Yeah.
Yeah, I guess the other gateway. Yes.
There should be like my own encryption, right?
Right. Oh, good. Well, we've got a good response here. Let me put up the results of the poll. And a lot of cloud providers,
Oh, interesting.
fair amount that kind of new to this. I don't know. Michelle, you want any comments, any reactions to any surprises?
No, I think the cloud one is super interesting, and we're seeing this, you know, in our customer base too. I think there's been a move lately to kind of simplify a little bit what's happening in API gateways and to try to seek a little bit of simplicity there. And people are taking that opportunity to leverage the native tooling on the cloud providers that they're using. I think that's probably one of the most common things that we're seeing. There's also an expense equation, to be honest with you. Some of these platforms get pretty darn pricey, and what it makes people do is be really choosy about which APIs they load into them, because they don't want the pricing to go up, and then they don't have any of the management capabilities for those APIs they don't load. So I'm not too surprised to see this, and it makes sense in terms of hitting the balance of functionality and economics.
Very good. You know what, Nir, we'll come back to you in just a minute. I'm just thinking about, you know, we have had, you know, web application firewalls and API gateways, things like that. Talk a little bit, Michelle, about what this next generation of API security looks like and how it might be different from that. You mentioned the tools of the last 10 or 20 years.
Yeah, I think a lot of it's tied into how you talked about the topology changing, and everything that Nir's describing about the Finastra infrastructure bears that out. There's a lot of internal dynamics here. So I think what you really see in these first generation tools is a pretty narrow scope of deployment, can sit in kind of a narrow space. It sees things in a fairly narrow way. It's deployed in line as a proxy typically, and so there's some deployment challenges that go with that. But the real fundamental limitation is that it's looking transaction by transaction and saying, is this valid or not? And it has no notion beyond that one transaction that it's evaluating at this particular moment. And the problem with APIs is that if you think about, like, a good analogy is thinking about how the world changed from AV to EDR, right? AV was all about a known bad thing. I have a signature, I block that thing, I'm all good. It stopped being enough, right? Things were getting more nuanced, things were getting more complicated. The same things happened in API traffic. It's not enough to say, does this one thing in isolation right now fit something I already know, look okay or not look okay? APIs are much more complicated. They're unique. Nir's APIs are totally different to everybody else's APIs, right? And so you need a system that has a notion of context, that can stitch things together over time, can correlate things across millions or billions of data points and say, this is the same entity. Even though it's a different IP address or it's doing something in a different order, this is the same entity and I'm watching this entity. If you think about principles of zero trust and things like that, where you have to be continuously monitoring, that takes state, that takes context. And so that the big shortcoming from some of these first generation tools is they just weren't designed for this world. They were designed to look for one thing at one point in time and say yay or nay. And APIs are just, it doesn't fit the bill anymore.
It's interesting. It really correlates back to the conversation about inside outside thinking versus state and context and what's really happening. It's so much more dynamically in the application. It totally makes sense why API security is a much different thing than it maybe was in non-cloud native kind of architectures. Nir, I'm really interested. Tell us a little bit about your journey, your API journey, and going across the kind of architectures that you're implementing at your company. Tell us about how you approached API security.
So we prepared a slide for that, not surprisingly. So let me walk you through, the challenges that we had and the evaluation process that we had, because the challenge that we identified with API security is something that not only that came from us, it's something that also came from the regulators that talk to us quite frequently. And the same questions that we asked about, what happens with an API poster, specifically if you talk about financial services. There are specific business needs that we have to protect our APIs. One of the examples that we defined as a scenario that we want to protect against is account takeover. So one example can be, brute forcing or credential staffing against an API. It can happen through, stolen credentials. How many times you heard about that? Someone put credentials on a GitHub and ended up with, with a breach. And in some cases, it can also be a compromised app developer that calls their APIs and they store the keys in another place. It can be like on whatever environment variables they have, or maybe in a database. So at the end of the day, we don't care how the potential user or account was compromised. We want to protect against it. And there are multiple ways to do that. Actually, this is something that we co-engineered with Salt. For instance, today we identify when a B2B application calls us from, let's say, an abnormal IP address, or we identify what happens with a specific behavior against APIs when it's an API that app is not used to call. So let's say it's an app that calls, I don't know, payments, and suddenly, that API tries to call that app tries to call multiple APIs that are outside of payments. We will see that as an abnormal behavior. Same thing happens with not only the API endpoints, it happens with other parameters that we have in the payloads. So essentially, we want to understand not only where accounts can be taken over, we also want to know, when we see abnormal behavior in terms of anything that doesn't fit what we expect to see. Beyond that, it's also something that that helps fintechs to understand if they have any incident, because obviously we care about our security and our customer security. But if we have a way to benefit the fintechs and say, hey guys, we can see traffic from another IP address, that would also be beneficial for them. So that's how we look at that. Beyond that, there is a need that this is something that we identified in Finastra. The data classification is quite important. I know that some people call it as a checkbox. Hey, let's just classify data, right? We need to do it because the regulators ask. Well, we already had data classification when we've been asked about that. We had that per product, and we had that in the database level. But what we ended up with is classifying data in the APIs and in the Swagger files that we publish. So for instance, if you go to fusionfabric.cloud and download one of the OpenAPI specs, you will see a tag of what is classified as restricted and what is not. The reason why we do that, again, it's not only for our own benefit, it's also for the application developers. It can be also the fintechs, as I said, and they, sometimes it can be a small shop of like few guys in a garage that want to develop an app, and we can talk separately about how do we vet them from a security standpoint. But this is really a tool that we provide them so they can identify where the sensitive data is and how to protect that, because we have a specific legal clause about what they need to do with restricted data. And on top of that, of course, we have the rest of the technical attacks, and I call it OWASP API security top 10 attacks, because I'm just kind of trying to simplify the indirect object access and all the other injection attacks.
Well, I guess I'll think my buddy will withdraw our application for our app. So since you're going to
trying to sneak in.
As you're talking, Nir, I'm really curious. I mean, FinTech is different. Your role in FinTech is different because you're not just a financial institution. Your customers are financial institutions. They're going to be all over you about API security. So you're going to be held, I think, to a pretty high standard. Is that not true? I assume you get a lot of questions about this topic.
Yeah, we get quite a lot of questions about that, and this is the reason why we actually, it's outside of API security, but we actually spun up a security program for all of our apps in the marketplace. So every app, before it connects to even a UAT or a production tenant, they must go through a third-party vetting process. It's like a third-party risk management, but it's more technical, based on some sort of a BISN type of assessment or VBISN type of assessment that checks their processes, trainings, penetration testing last year, tools they have in the pipeline, data classification, whether they read data, whether they write data through our APIs. So all of that is something that we get, and myself and my team need to approve that as a gate before even being able to connect any app to production, or UAT, which is also a testing environment for the banks behind the platform.
Very good. And feel free to jump in, Michelle. Your time. One more question I want to give you too.
I'm learning a ton with Nir. I just want to hear him.
It's fascinating to hear. So you're obviously using SALT security as your part of this webinar. Tell us a little bit about your selection and why that's the direction that you went.
Well, that was a long story until we actually managed to find SALT. So I'll be brief about that. We started the journey by identifying the challenge. Once we identified the challenge, we said, well, it's a machine learning problem. We can solve it. And we actually developed the basic functionality that I just highlighted with regards to accessing, like the first two bullets that I just highlighted here on the left side. I wouldn't say that we developed the full functionality of that, but we definitely developed a functionality that is able to identify those attacks. It took us only a couple of days to develop it because we really have really good data scientists in the company, and then we started calculating the cost. So we realized that we need data scientists because we need to adjust the models. We need some UI. Would likely need someone to review the false positives and have a technical way to adjust the models, learn new features, operate that like a DevOps option, function. And long story short, we ended up with a TCO that ended up with almost 3x of what we're paying today to solve. Okay, so it was a good decision not to develop it by ourselves. Now, we did a couple of POCs with a couple of vendors, and and the way that we do POCs in Finastra is not that we go to the vendor and say, show me what you have. Sorry. The way that it works is that we go to a vendor and say, this is what we expect to see. Do you have this functionality? If there's anything beyond that, we'd be happy to hear about that, but usually it's we tell, don't ask, okay? And this is what we did with Salt. And one of the examples that we highlighted is that we know very well how web application firewalls work. We have them, they're deployed all over, but for me, it's important to see the user context, meaning when a user authenticates, let's say he gets a token, I want you to interpret the token, build a model based on that token, based on the permissions on that token, and tell me what is abnormal. It's a very specific ask that we came with to Salt, and eventually, we managed to get that working. And this is the other thing that that we couldn't find with other tools. And the last thing that we were looking at is how can we investigate incidents when they occur? And many tools focus on logs and events, but I care less about the log itself. I care more about the context. How quickly can I triage the issue? And what is the history of that attacker? Specifically, again, this is an identity context. And this is something that we actually got at the first POC, that it was just literally a couple of hours in the POC when we saw that. So this is pretty much why we went to a API security solution. Do you have any questions about
that? No. Well, first of all, if you don't take anything else away from this conversation, going from wandering in the wilderness to was 3x cheaper to go this direction, I'd note that if you're thinking about developing something yourself. So maybe what could do, Michelle, can you kind of connect the dots for us about Salt and the capabilities that you all have and how that might fit into the elements that Nir has talked about?
Yeah, I think, Nir, you raised a bunch of points about what was important in making this operationally effective. I think that's, it's one thing to look at a demo, but it's another to really think about how you're going to run this, and is it pragmatic, and is it, I loved what you said. It's such good advice. Tell them what you need. Don't just ask them to show you what they have. I think that's a fantastic bar that the audience should really hold their vendors to. It's actually welcome to hear that, welcome news, because when somebody is that clear about what they need, you know exactly what to do to work with them as a partner. It just makes everything a lot more crisp. So I think that's another great takeaway, is define your needs in advance, gives a lot of clarity to the POC process. So, some of the other things Nir touched on, he talked about the deployment of the WAFs. We have them all over. one thing I have yet to meet a person who's like, I love my WAF. It's awesome. Like that just doesn't happen. People are grumpy about their WAFs, and they take a lot of, constant upkeep and investment to tune. And it's another area where we hear like, if I could ask less of my WAF and have more sophistication elsewhere in my system that was seeing more places, collecting more data, brought me more context, I would have better security. And so we see that a lot. So one of the principles about how the SALT architecture is created is to deploy in a very simple way and to deploy in a really ubiquitous way. So we can drop into any kind of application environment and we're not sitting in line. So, you've got that broad purview of everything. You're seeing the broad collection of API traffic. And, Nir's point around, he's really focused around identity context. Sometimes it's app pattern context, but whatever it is, the context really matters. And so you need to see that over time. And to do that, you need to collect a whole bunch of stuff, and then you need to process a whole bunch of stuff. And Nir talked to the notion of like, yeah, we have really smart data scientists, and they could go do this. That's how we've been architected. We couldn't have built the SALT platform more than a few years ago because the technology to do it wasn't there. So we're collecting all that API traffic, and then we're funneling it into our big data engine, and then applying AI and ML to do that tuning, to do that learning, so we see what's happening. So the discovery is very comprehensive, right? You're seeing all your APIs, you're seeing all the data they expose. And then Nir talked about, and he's been a fantastic development partner as well. His bar is really high, and that's good for us because we make a better product because of what he needs. And that notion of like understanding the attacker timeline, it's really valuable. You need to, what we do to against that big data engine is then look for those points of abnormal behavior and very quickly have to ascertain, is this different because the API changed? And so everybody's doing this thing in a different way, or is this different in a malicious way? It's only one entity that's doing it differently. They're calling things they shouldn't be calling. They're calling a greater number of volume of things than they should be calling, and then selecting that out and alerting on that, and alerting on it once, right? So giving Nir the ability to say, this is an attacker, one alert, go profile. Do you want us to automatically do things? Do you want to manually do things? So finding and stopping those attacks, doing it early, during recon. It's really interesting. There's a kind of a fine line. You have a little time with APIs. It's not a one and done thing with an API attack. It's not like if they do this one successful call, bam, you just lost everything. Because they're doing all these recon efforts to try to understand what your API does, what it talks to, what kind of information they can gather. So you've got a little time during that low and slow process to gather things up, correlate it, pinpoint it, say, yes, this is an attacker, and then stop that attacker. And then, the last area that SALT's really focused on, and Nir can talk a little bit about what principles do you apply more left side, what principles do you apply more right side in terms of building it into dev versus runtime security. But we also think it's important for security in this arena to be a really good corporate citizen and bring back to dev teams areas where the APIs could be improved. So if we're collecting everything into that attacker profile, and they had little tiny successes along the way, not the ultimate success, they didn't achieve their objective, but they had little successes along the way, how do we surface that for Nir in a way that makes it easy for him to bring that over to his dev teams and say, hey, we can make an improvement in the APIs here, here, and here to remove a weakness in how that API was written. So in a nutshell, the architecture is built to deploy in a very simple way, deploy holistically, see all the API traffic, do all this broad discovery, enforce, and actually I'll make the point because it's not intuitive. We don't deploy in line because we don't want to disrupt the app in any way, and we don't want to have a complicated deployment. But to enforce, you have to be in line. And so what we do is we take our learnings and we tie back into, and I think Nir will show this a little bit in terms of his deployment, we tie back into the devices that you do have in line, the WAFs, the API gateways, your F5s, things like that, and enact a policy on those devices to take the action in line. So easy to roll us out, holistic view, we surface good stuff, and then you do integrations into your inline devices to take action against those
Really interesting.
malicious behavior.
Yeah, the deployment model is, I think, unique and it has some key advantages. Nir, maybe you could share with us your process of how you integrate and employ this with the systems that you work with, but also address, you know, developers using tools, right? These tools generally don't come from out on high. The CIO doesn't say, "Thou shalt use Salt," right? Developers will say, "Yeah, we're going to use what we like." So, talk about the adoption of Salt in this approach, as well as how you rolled it out in your applications.
All right, I will cover that here. And I know we have slides just to have the talking points, but the true content is that, you know, we were looking for very specific capabilities, as I just highlighted, of course, right? You know, very specific, you know, technological security capabilities, but also, you know, in terms of deployment, the initial conversation that we had with Salt was, you know, back then was something that was a typical deployment for their customers on VMs. Well, we don't have VMs in our platform. Everything is either platform as a service or Kubernetes based. Everything is on containers. So we had that, you know, conversation and got the commitment from Salt to containerize the entire thing. And the way that we deploy Salt today, it's called a hybrid deployment, which means that the payload itself, well, Salt supports it, but the payload itself is not sent directly to the cloud, to Salt's cloud. It is sent to our own containers. All of the sensitive data, so-called, is on our premises, so we don't need to, you know, if we had to do any security certification, we wouldn't want to get, you know, Salt into that scope, of course, and no any other vendor. And this is how we kind of contain all of the sensitive data that we have. Now, all of the data, as of today, is sorry, not all of the data, all of the containers, they're actually deployed as part of a full CI/CD pipeline today. When Salt needs to, you know, to release a new container, this is something that also goes through a pull request through my team, which means that we know that it came from a trusted source. We know we can confirm that, you know, we don't have supply chain attacks because we'll also have the, you know, our security tools scanning the Salt containers, and it's essentially fully automated and almost autonomous deployment as of today. And the last one, and I will walk through the architecture in a moment, is actually the workflow integration. And as Michelle said, we don't want to have yet another device tapped into our network. We don't want to see more latency. We don't want any additional breaking changes if something happens. And that's why the workflow integration is so important, because all we want to do is to get a notification and then decide what to do with it. Where, you know, when you see a user context, it's really difficult to block a unique request. And in many cases, you can't really do much with a unique request. For instance, if you want to, you know, identify a, you know, let's say account takeover, and you want to disable an access to all tenants that FinTech has access to, you need to go and find who are the tenants that this FinTech is connected to, and then disable the consent or the access to prevent, you know, any exfiltration or any, you know, any attack essentially that happens in that realm. You want to stop this account. You can also disable the account, but you need to understand which account exactly it is. So there's some logic that you need to do inside the company to make that decision. Therefore, the workflow integration is important for us, at least, to do the homework when we get the alert, and then trigger the action based on that. So that kind of explains the reason why we called out those requirements. If there are no questions, I can talk a bit more about the architecture, or Michelle, if I'm missing anything, please chime in.
I think the architecture would be great and then we have some
Yeah,
questions
let's do
too.
that. Yeah, that's
We
perfect.
list the architecture because I think that'll maybe set the
It might
context.
prompt, yeah, exactly, and prompt some more questions.
Go ahead, Nir. Architecture. Architecture away.
Architecture myself. Okay, so this is, the simplest way I could put it. But that kind of explains what we're doing. I mean, I think, Michelle, you mentioned that there are some things we're doing on the left side, there are some things we're doing on the right side. What I wanted to bring to the conversation here today is what we're actually doing on the right side and the workflow automation that we already have in place, at least in some areas. And if you think about the workflow, what we have is, yes, of course, we have WAFs, and this is kind of more of a regulatory checkbox than the protection that we rely on. Yes, there are certain good protections that come up with WAFs, like you can put some thresholds on request, and you can get generic attacks that you can prevent. So it's not true that it's not necessary at all, but the true value that I'm looking for is the value of the user context. And as you saw the poll, most of you have any API gateway. So the way that it works is that it goes to an API gateway, and at least if you look at the architecture like our platform, we have certain technical services that run on Kubernetes. Can be like a token management and tenant management and telemetry, organizations management and such. And essentially, once we get the entire context that we need, then the request is routed into the financial institution or the multiple financial institutions we have behind the platform. And every call, the request and response that is sent either to the microservices or to the financial institution is recorded within the Salt hybrid deployment that we have. The Salt hybrid deployment doesn't send any sensitive data into the cloud. All of the machine learning models are deployed on our premises, and when an attack is identified, or getting some additional telemetry data, of course, all of that is sent into Salt. And then with Salt, we have several webhooks. We have, for example, a webhook that our app ops or engineering team wants to get, because sometimes if there is an alert that comes from Salt, they want to get that alert and know to react to that. So we have a Teams channel in which we send all of those webhooks into that channel. Another interesting webhook is actually I'll call it here for the purpose of simplification, a function. And that function gets the alert, identifies the source IP, the type of attack, and essentially all of the checks that we want to have in place. Of course, if we need to do any additional processing, get more context, this is what that function does. And if the function decided that this is an attacker that we need to block, it can take an action. Either can be like something that disables an account, or if, let's say, it's an IP address that we want to block, then the function goes directly to our web application firewall and blocks this IP address. Of course, you can go with multiple combinations with this, but this is really a high level of something that is not deployed in line, can actually make blocking decisions. So this is really high level on the right side. Maybe I can touch on the left side. I don't have a slide for that, but on the left side, one of the functionality that Salt has, and today, yes, it's a security tool, but today we see more and more involvement into things beyond security. So for instance, one of the the interesting calls we had recently with the Salt team is a call about open API specifications. We want to know if the open API swaggers that we deploy are aligned with what Salt sees initially in our user acceptance test in the UAT environment. And then, of course, we'll check that in production. But this is how you take the most right solution that sees traffic and compare that to what we have. Because, as I said, we already have a data classification process, but we want to double check the data classification, not only based on what we understand from the business owners that actually developed the swaggers, but also from the traffic that we actually see. So this is like the wide spectrum of left to right in terms of looking at APIs. Ideally, you look at those APIs from the moment they're deployed until you monitor them. And that's all I have. Some time for questions.
That's really interesting. Just to round out from what you're saying, Nir, one of the other findings in the State of API Security report that we just published yesterday had to do with this question of like, at what phase of the API lifecycle are you trying to apply protection, right? Build, deploy, run, test, etc. And I think your depiction here of, you need to monitor them constantly. You need to be looking at them during build to make them as strong as possible, but then you also need to be looking at them in runtime and doing that continuous monitoring. I think that's a really important revelation. There's been this huge push to shift left, and it's really valuable and it's noble, and we should absolutely be doing it, but it's not everything. And what we found in the survey results was 54% of respondents were not doing any runtime monitoring for API security, and 91% of them had a security incident. So that means doing left side stuff, while important, and by left side, guys, we mean like this whole shift left, right? Moving security principles to apply during build and development. It's important, it's insufficient. And so having that mix and having that API security really apply across the full life cycle. I think, Nir's depiction of how he's instrumenting that within Finastra, I think, is a great example, because it is important to do it on the left side and the right side, to do it in build and in runtime.
There's a really great question. Thank you, Michelle, that Samuel asked from our audience, our participants, that I think falls into this architecture. When do things apply? When do you do security? Samuel's question is, do your microservices have no internal security model, i.e., do you depend entirely upon externals, the API gateway / web application firewall for security? Nir, you want to take that, please?
Yeah, so there are multiple ways to look at API security, and this is all deployment models that Salt supports. This is something that we discussed several times. The way that you should look at that, it's really up to what you're trying to protect. If you have like a service mesh, at the end of the day, you have a hub or router, it really depends which vendor you use, that sees that traffic and routes it. And you can use all of that to forward the request into Salt. Now, not only that, in fact, we support additional use cases in which this is what you see here in the architecture diagram. It's something called APIs, but we also have something called SPIs, which is an extension of our APIs, and that goes outside of our premises into a FinTech. An example would be a FinTech that identifies payment fraud that is called through those APIs. And we see all of that. And if there is another service that pulls those other services, if you put the Salt hybrid in the right place and you are duplicating the requests and sending them to the Salt hybrid, it will identify that. It doesn't matter where it comes from. And in fact, one of our deployments works exactly that way, where all of our requests, including internal requests, are sent through Salt well, not through, copy salt more technically.
Yeah, I mean, so the short answer is you have internal controls. That's not possible with the WAFs and the gateways. You're doing this, in this particular case, you're doing it with salt. But I think a lot of people struggle with that, right? Microservices are not going to be well protected with those older technologies that just weren't built for that model.
I think that that's where the intersection of the being able to leverage the web application firewalls as that point of protection, but all the context and the intelligence, if you will, of what the app inside the app is doing. Its architecture, the microservices, how the mesh is built, what functions are being formed. That context is all extremely valuable to know that you're taking the right measures when you do take those, correct?
Yeah, and it's really a matter of it's a matter of what each company perceives as its own risk, right? So for instance, if you develop microservices and they don't need to authenticate between each other, well, you should probably have something like Salt to identify that, right? Because you will see abnormal requests coming in. You will not see abnormal users, but you will definitely see abnormal requests, right? On the flip side, even if you have authentication, is there any probability that you have a multi-cloud deployment? If you have a multi-cloud deployment, then is there a chance that a service that is not familiar in this mesh sends a request to another mesh? So there's a lot of problems or challenges to solve, you know, when you talk about inter-service communications, but it's really up to your company's creativity and architecture to define what type of anomalies and where you want to find them.
Yeah, I think you've kind of started us down this path with those examples. Nir, Amos from our participants today asked if we could hear about sort of best practices, tips, things that you've learned going through this. You talked about, you know, microservices that may not have authentication between them. Are there any other tips or lessons learned? I'm sure you've got some real kind of interesting, you know, now that you've done this, you'd love to share a few things with folks.
Yeah, so I think we'll start with, you know, usually when you get into a company and look at the security posture, you usually look at NIST CSF, right? This is like the first thing that you do. If you look at APIs and say, oh, us top 10 API security would be a good start to look at in terms of, you know, what type of attacks and what are the common things that happen in API security. But then once you're acclimated with this, I'd say that the next step is really getting to those webinars and go to those talks and see what others are trying to solve, because as I said, we have one type of architecture, other companies have different types of architecture, and this is the way to learn more about those types of solutions. It's a fairly new space, right? So
It is.
It's really difficult to say, hey, this is the best practice for API security. It doesn't work that way.
Michelle, were there any interesting things that might have come out of the report or anything you've observed working with your customers? Any other tips or suggestions?
Yeah, I think there's a couple of things. I think the first is, you know, the frameworks that Nir highlighted are really valuable because you just need a way to think about it. I think the other thing is, you know, recognizing again that developers think differently than security teams, right? They don't think from an attack standpoint. And so, you know, a little bit shaking loose some of the old assumptions around how protected you are. I think that that's one of the big mindset shifts that changes everything, is when people begin to recognize the complexity of what's happening with APIs, the way that they're unique to every organization, and the way that, you know, manual-based tools, signature-based tools, or tools that take a whole bunch of configuration and tuning, they're just not going to keep up in this world. You don't have the bandwidth to keep doing this. And developers change things all the time, roll things out all the time. So this notion of dynamic and continuous is really valuable. So I think the awareness, having the discussion, getting these teams together so that security teams can get some insights as to what's happening with these APIs. They're not living in this world every day. So helping them understand the point of the APIs and the scope of them, and then looking together at how you're going to apply some of these tips and tricks like Nir just talked about. It's going to be unique for every org.
Something that I'm curious about too, data security is a huge topic, especially when we're talking about cloud environments. You mentioned multi-cloud as well. Nir, how do you keep your own sensitive data safe if you access salt info on a cloud service and something like that? Whoever would like to take that question?
That is actually very simple. With Salt, they don't store the data. Everything we send to them is getting as an input to the machine learning model, and then drop out. So it's only in memory, only in the container, and it's never sent out of the container into the cloud. Hence, it doesn't matter, which type of sensitive data we have. It technically doesn't leave our premises. Okay? There are other aspects on how you store data security and such, but in terms of like API security and applying a security protection product, it should never store any sensitive data. That's the short answer for that.
Great. Nice to hear somebody say that's simple, Michelle. I wasn't expecting that answer. That was not a softball question.
He's not alone though, right? I mean, that's a big deal for everybody, because the whole point is that we're helping you understand your attack surface, and we're helping you understand, exposed data as part of that attack surface. And yet we recognize that we can't hold any of that. And so it's only metadata that goes up to the Salt cloud, like Nir mentioned.
Excellent. We've got a few minutes left. I need to have a little bit of housekeeping and need maybe a minute or two before we get to the top of the hour. But one other question that we had come in was, what does the API gateway product do for you versus what does the API security platform? What does it protect you from? How do you explain that to developers so that they're clear on these things? This is what the API gateways are doing. This is what we're concerned about on the API security platform.
The way that I'm looking at that is that API gateway is a good gate that you have a handle on it, right? You don't have a key, you just have the gate, okay? And when you approach that gate, the gate can tell you a lot. It can tell you the number of the house, can tell you probably who lives there, meaning share with you which swaggers you have, or get you the access into the property. But then when you get into the building, you need to have a key, and Salt is that key. Okay, so you will get where you need to get because API gateways essentially kind of give you the access where you need to get to. Similarly, as a firewall, it gives you an access where you're supposed to get access to. But then the details of how do you react to, let's say, someone who tries to break into your house, this is the shift right approach in which you get the data, you see the camera on ring, and then you call 911. I hope that I simplify that somehow.
No, that's great. It's a good analogy. We might steal that, Nir.
There you go. It is. Yeah. Salt is the key too. It kind of fits the whole spirit.
We're the ring doorbell.
Exactly. Well, we're just about at the top of the hour. I want to respect everybody's time in this land of COVID and Zoom calls. We always have something coming up right after this thing, whatever this thing is. So, both of you, fantastic job. Really appreciate you sharing your knowledge and experience. API security is such a huge topic right now, and hopefully, just looking at their kind of engagement from the audience, I think you've done a really good job of hitting the mark on some of the questions that they've had. To that point, everybody that's with us today, we will have this available as the recording. You'll get the email with this in the slides, and of course, you can get that on securityboulevard.com. Also, share the recording with your friends, with other developers, architects, software folks, DevOps engineers, whoever it might be, security teams. Because this is such a relevant topic at the moment, feel free to forward that email on to other folks in your network that you work with that you think this might be helpful. maybe we can help us all make some progress in the world of API security. So let me wrap up just with one last thing, and that's our gift cards. We're giving away 4 Amazon $25 gift cards, and the winners of those are David M., Andrew K., Mary C., and Stephen, I'm not sure, Stephen L. The folks here at securityboulevard.com will get a hold of you about getting hold of those gift cards, maybe pay a few of those Christmas bills off, the holiday bills. They might be hanging around there still. So it's been a great pleasure to be with all of you today, and I especially thank Nir Valtman with Finastra and Michelle McLean from SALT. Both been fantastic. We appreciate everyone being with us today. Your time is extremely valuable. The fact that you would spend an hour with us, we're honored that you've been here today. Thank you so much.
Thank you. Thank you, Nir. It's great to be with you.
Michelle, Mitch.
Thanks, Mitch.